Ever wondered how the sun's energy is harnessed to power your home? Imagine the sun, a celestial body light years away, powering up your coffee maker every morning. This is the magic of solar panels. These unassuming slabs play a crucial role in harnessing renewable energy, converting sunlight into electricity. It might sound like a feat of wizardry, but it's grounded in pure science. With the sun as our infinite power source, we're tapping into a future of sustainable energy. Let's dive into the fascinating process of how these solar panels are made. Did you know that solar panels start their life as sand? Yes, it's true. Our journey towards harnessing the sun's power begins with the humble grain of sand. Sand is abundant and makes up about 90% of the Earth's crust. This ordinary and seemingly insignificant substance is the primary source of silicon, the superstar material in solar panels. But how do we get from sand to silicon? The process is fascinating and involves several stages. The first step is mining. Sand is extracted from the earth, usually from a quarry or a beach. This is a crucial step because the quality of the sand impacts the efficiency of the final product. The sand must contain a high percentage of silicon dioxide, which is the raw material needed to create silicon. Once the sand has been mined, it's time for purification. The sand is heated to extremely high temperatures to separate the silicon from the oxygen. This process creates metallurgical-grade silicon, which is about 98% pure. But we need to purify it even more for it to be used in solar panels. The silicon is combined with hydrochloric acid to produce a gas. This gas is then reduced with hydrogen to create polysilicon, a material that is over 99.999% pure silicon. The purified silicon is then melted in a furnace at temperatures over 2000 degrees Celsius. This molten silicon is carefully cooled to form a single crystal structure, creating what is known as a silicon ingot. The ingot is a large block of silicon, which is then sliced into slim square wafers. These wafers form the base upon which solar cells are built, capturing and converting sunlight into electricity. It's a complex, meticulous process, but it's also a testament to human ingenuity. We've taken something as commonplace as sand and turned it into a key component of renewable energy technology. So, the next time you're at the beach, remember that sand could one day power your home. From a block of silicon to thin wafers, this is where precision comes into play. Transforming a solid block of silicon into thin, uniform wafers is a meticulous process that demands absolute accuracy. Imagine a loaf of bread, but instead of slicing bread, we're slicing silicon, a material much harder and more brittle. The silicon block, or boule, is mounted onto a specialized machine that employs a multi-wire saw. This saw is not your typical tool. It's an intricate device that uses a slurry of silicon carbide or diamond particles to cut the silicon boule into wafer-thin slices. This operation is about more than just chopping up silicon. It's about ensuring each slice is consistent in thickness and free from defects. Even the slightest deviation can affect the performance of the final product, the solar cell. The result? A stack of pure, thin, and nearly transparent silicon wafers, ready for the next stage of the process. Just like that, we have our silicon wafers, the canvas for our solar cells. Now, it's time to transform these silicon wafers into solar cells. The first step in this transformation process is called doping. This is not your typical athletic scandal, though. Doping is a process where we introduce impurities into the silicon wafer. It sounds counterintuitive, doesn't it? But here's the magic. These impurities create a positive-negative junction, a critical element in enabling the flow of electricity. Imagine you're at a party. The room is filled with people, but no one is dancing. Suddenly, a groovy tune strikes up and a couple of partygoers start to bust a move. Their energy is infectious and soon the dance floor is filled. This is what happens in a silicon wafer. The impurities or dopants are like those first few dancers, sparking a flow of energy throughout the room, or in our case, the silicon wafer. Next, we coat the silicon wafer with an anti-reflective layer. The sun is our main dancer, and we don't want its energy bouncing off the solar cell. This anti-reflective coating ensures that as much sunlight as possible is absorbed rather than reflected. It's like turning the lights down low at our party, so everyone can focus on their dance moves. The last step is printing. We use a screen printing process to apply a grid of metallic conductors onto the silicon wafer. This grid acts like the DJ at our party, directing the flow of energy, or in this case, the flow of electrons. It's the conductor's job to ensure that the energy captured from the sunlight is transported efficiently to where it's needed. So, to recap, we dope the silicon to create a positive-negative junction, coat it to capture as much sunlight as possible, and then print a metallic grid to direct the flow of electricity. Each of these steps is crucial in creating a structure that can convert sunlight into usable electricity. And voila, we have our solar cells, the heart of our solar panels. With our solar cells ready, it's time to assemble the solar panel. Let's dive right into the process, shall we? The first step is arranging the solar cells. This is not just a simple task of placing them together. The cells are arranged in a specific pattern that allows for maximum sunlight absorption. The pattern also helps in the efficient flow of electricity. This careful arrangement is a testament to the meticulous engineering that goes into every solar panel. Once the cells are arranged, we move on to the next step, laminating. Lamination is an essential process that serves as a protective layer for the solar cells. The cells are sandwiched between sheets of ethylene vinyl acetate, or EVA for short. This material is transparent, allowing sunlight to pass through, and it also creates a waterproof seal to protect the solar cells from harsh weather conditions. The EVA encapsulated cells are then placed between a sturdy back sheet and a tempered glass front sheet. This combination not only provides additional protection, but also ensures the panel's durability. After lamination, it's time for framing. The frame is usually made of aluminum, which is both lightweight and robust. It serves as a rigid structure that holds everything together. The framing process also includes the installation of junction boxes and electrical connections. These are crucial components that allow the panel to be connected to an electrical circuit and start delivering power. The assembly process is a critical phase in solar panel production. It's all about protecting those delicate solar cells and ensuring the panel's efficiency and durability. It goes to show that every step in creating a solar panel is as important as the last, each contributing to the marvel of engineering that is a solar panel. From sand to a complete solar panel, isn't it an amazing journey? It's fascinating to see how we can harness the power of the sun, turning tiny grains of sand into a device that can power our homes, our cities, and maybe someday our planet. But what does this all mean for you and me? Well, let's break it down. At its core, the beauty of solar panels lies in their ability to harness the sun's energy, a resource that's not just abundant, but also completely renewable. Unlike fossil fuels, which are finite and harmful to our planet, the sun is an endless source of power. It's always there, day in, day out, generously showering us with more energy than we could ever possibly use. But it's not just about the abundance of solar energy. It's also about what this means for our electricity bills. Traditional energy sources can be expensive, and they're subject to price fluctuations. Solar energy, on the other hand, is free. Once you've installed your solar panels, you're essentially producing your own electricity. This could significantly reduce your electricity bills, and in some cases, you might even generate more power than you use. Imagine that. A world where you're not just a consumer, but also a producer of energy. Beyond the financial benefits, there's also the environmental impact to consider. Traditional energy production methods often involve burning fossil fuels, which contributes to air pollution and climate change. Solar panels, however, are clean and green. They produce electricity without releasing harmful greenhouse gases into the atmosphere. By choosing solar, you're not just saving money, you're also doing your part to save the planet. Now let's cast our gaze into the future. The technology behind solar panels is constantly evolving, becoming more efficient and affordable with each passing year. Researchers are exploring new materials and designs, aiming to capture even more of the sun's power. And as solar becomes more mainstream, we're seeing innovative applications, from solar-powered cars to entire solar-powered cities. The possibilities are endless. In conclusion, solar panels offer a way to not just harness the power of the sun, but also to transform our relationship with energy. They empower us to become producers, not just consumers. They help us save money while also saving the planet. And they're a key player in the transition towards a more sustainable, renewable energy future. Harnessing the power of the sun, one solar panel at a time. That's the magic of solar energy.